Techtalk series has so far had 8 shows. This is the 9th one that we're doing. Typically, we've had it at 1800 hours India time, which therefore, collides into something in the morning in the United States. Those coming from the eastern seaboard, like Indrani, for instance, have a different time from those who come from the Midwest, like Mary. Well, the thing about this Techtalk series is that over these 8 sessions that we have so far had, each lasting about 75 minutes, we have had some very distinctive takeaways for people seeking solutions in India. I can take 2 examples which seem to stand out. One is a town of about a million population in Peninsular India. It's called Trichy, and they are looking at how one of these technology providers from the US that Mary introduced to this distinguished leader group is now going to take up and see how they can come up with something with reasonable cost and good, effective technology solutions for restoring a lake in that town. The other one is that there is a person called Adam Tank. I think he's from the Eastern Seaboard again, somewhere in New Jersey, and this guy has offered a very interesting solution where he says you could take a dirty wastewater waterway, and he puts in a system that's a continuing water treatment process in a way that a city can clean up its wastewater canals. Well, we are trying to see what we can do to push all this between Mary, me, and a few others like that. So the idea is to see how we can, shall I say, midwife processes where solutions can not just be technologically effective, but also in terms of cost for Indian cities or for Indian companies and Indian organizations. That's all from me for just now. Good morning once again, Mary. Over to you to take the mic and see how you want to lead the meeting. Yeah.
Yes, Hari, just a pleasure to be here again and to see you, Usha, and to have Doug and Mark from 374 Water, relatively new initiative out of Duke University, known for its energy innovation. They were able to couple with a energy provider to go public. And so you can already invest in 374 Water. As you hear their story, you'll understand why, because they are a truly disruptive technology that has the potential to shift global waste management from treatment to resource recovery. And what you'll hear is about how the high temperatures, applied to waste allows them to secure water and also to secure and potentially remarket the minerals and the elements within the waste stream that they are treating. And Doug is a friend, an individual that I've seen through the water sector for the number of years I've been in it. He's usually representing something that's a breakthrough, very exciting technology. And he's the Chief Revenue Officer, a great positioning for anything in water. As we know, revenue is often not the first thing people think of. They all want their water for free. So we're going to learn from Doug both on how to get into the market, but also about 374 and the different ways that you can participate. I'm thrilled that he's brought along his colleague, Mark. I'll have him introduce Mark, but just want you to know that Doug is experienced in commercializing water. He understands the different ways to sell water as a service, and he's going to share about the supercritical water oxidation for their technology that allows them to recover resources and also treat PFAS, which I know is not as big an issue here in India, but it can address microplastics, pharmaceuticals, and much more. He is also president of the consultancy Environmental Business Ventures. So with these tech talks, it's really wonderful, Doug. I just want you to know you're going to hear from a number of experts after. We'd like them all to consider where this technology could be applied. In what ways would it be best to invest or fund a venture so that they could prove out this technology in India? And I know that you also have a background with Global Access, which I believe is a Microsoft Foundation or Bill Gates Foundation effort to extend your capabilities into India and potentially to poorer areas that can't be otherwise served. And if you could explain how that works, that would be wonderful. And I'll let you introduce Mark at the appropriate time, but it's a pleasure to have you both with us. We will have these programs recorded, and I'll put a link in so that everyone can find those. And we at Global Waterworks also invite you all to continue to network. Frank and I, as Hari mentioned, have built a open community for collaboration on water initiatives. And we are working on the lakes recovery, as well as on water efficiency, on water quality issues, and just welcome anyone who has success stories to share, that we can all help paint a picture to a brighter water future that is more easily achievable because of the simple approach that the World of Water Forum has provided. So with that, I'll, Hari, unless you have anything else to add, I'll turn it over to Doug.
Thanks, Doug. I need to acknowledge the presence of Benedict Parmanand. Hi, Ben. Thank you for being here. He's the editor of something called Sustainability Next.in, and you can check this out. This is a Bangalore-based India journal, which documents very meticulously processes, developments in these areas at the frontier of technology or of basic development on natural resource processes. That's been there for you. Then we have got Sanjay Gupta from Hyderabad, who is going to be our next prospect on starting a WOW mission there. Sanjay, good evening. Namaste to you. Yeah. We also have Professor Swaminathan from the Indian Institute of Technology, Madras, IIT Madras. He was a professor there. He's retired, very keen on understanding larger processes beyond what consumers can do at their own levels of solutions and such. And this one that Doug is going to present today absolutely fits in very snugly there. Over to you now, Doug. Your time.
Thank you all very much. We're very happy to be here. I'm Doug Hattler. As we stated, I'm an environmental engineer, environmental scientist. I started in the hazardous waste and then moved into a lot of different roles, pharmaceutical industry, and now in the water and wastewater industry. Very pleased to be here. My colleague, Dr. Mark DeSuze, is our head of technology. Mark is also a tenured professor at Duke University in the Department of Civil and Environmental Engineering. Mark is the initial principal researcher that led to the research and development of this technology called AirSCWO we're going to present. It initially started with a grant from the Bill and Melinda Gates Foundation and progressed since then. He and his co-founder, Kobe Nagar, spun the company off created the company, in 2018. And we've licensed the technology from Duke University, and we're now commercializing what we call AirSCWO, SCWO being supercritical water oxidation. As part of our commercialization efforts and as part of our license and the work that originated from an initial grant from Bill and Melinda Gates Foundation, we have a program called Global Access. And Mark is heading up that initiative, and he's going to speak to that. We're also obviously going to introduce our company, and we're going to introduce the technology. But the global access is something that goes back to the very roots of creating this technology, and we're very excited to have this opportunity to let you all be aware of this program. And we hope that there's a fit here for technology and further discussion. The company itself, we consider ourselves to be bigger than just selling wastewater equipment or waste treatment equipment. We see ourselves as a social impact clean tech company. We're a virtual company, but we're based out of Durham, North Carolina in the USA. We are a corporation, and we are publicly traded right now on what they call the over-the-counter exchange. We are in the process of uplisting ourselves to the NASDAQ exchange later in this year. What we're doing is we're taking what the world views as waste, moving it through our technology, a kind of a blue box, and coming back to having clean water. I want to skip ahead. I'll come back to that slide. But we have a vision, and our vision is a world without waste. And you see that diagram is really what we mean by that is we're contributing to a circular economy where we can take the wastes that our society generates. We can take the waste that our society is generating, and we can break them down into the fundamental components of water, carbon dioxide, innocuous minerals that have a potential recovery and reuse potential, and heat. We recapture energy as heat, and depending on the size of our units, it could be converted into electricity through an expander technology that would then put energy back into for reuse. So that's the idea behind what we call resource recovery. We do want to, our mission is to preserve a clean and healthy environment that sustains life. We recognize the sustainability development goals under the United Nations. The 7 nations achieve their own individual goals around those. And then we have values. We own, we transform, we trust, we learn, we impact, and we dare as a company. I'm going to go back here a second. Let me see. I got one slide out of, yeah, I'm going to go back here a second. And, what we're trying to do with our global access program and around the world, but particularly in global access, is you can see, those 2 people are pouring essentially a 55-gallon drum of fecal matter. And in that particular country, this may be the norm for how it's disposed of. But that organic waste has 250 kilowatt per hours of power, which is a valuable resource. At this point, Mark, I'll let you comment because this takes you back to your roots, and then we'll skip ahead to that first slide that talks about the fundamental process underlying our technology.
Sure, and thank you. Thank you, everyone. Thank you, Mary, as well, to give us an opportunity to talk. Very pleased to be able to present this technology. So indeed, yes, this is when we started. 2013 is when the Gates Foundation was looking for ways to get rid of this problem. And we realized that there's significant energy embedded in that waste. And the challenge was, can we use that energy to turn this waste into something clean, recover resources, and avoid a lot of environmental and health problems. And the answer is that we came up with is this technology that we'll be talking about, and we're now commercializing, the supercritical water oxidation, or SCWO. Greg, if you go 2 slides forwards, we have here. I'll tell you a little bit about the science, and then show you some of the features of our system, and then focus on global access and what it means. So this is the phase diagram of water, and probably everyone is familiar, of course, with water as a vapor, solid, or a liquid. But you should also know that when you compress the water above 220 atmosphere and heat it above 374 degrees C, hence the name of our company, the water gets supercritical. It is not a gas, it is not a liquid, but it has some amazing properties of both. Since oxygen is fully soluble, the organics are fully soluble in supercritical water. And so what that means is that, and there's also extremely rapid heat and mass transfer. So what that means, next slide, is that when you inject air into organic waste in a slurry that's been brought to supercritical, the following reaction is happening. All the organics get oxidized, recover clean water, can be reused. The carbonaceous materials are converted to CO2. Minerals fall out of solution, are readily available for reuse as a fertilizer. And then you recover the heat of reaction, because it's an oxidation, because of all that energy that I was showing earlier, is recovered and is generally re-injected into the process, because you want to make it a continuous process. And some of the surplus can be turned into electricity. So that's the gist of the SCWO reaction. And on the next slide is shown how we've engineered it to fit into a box that can then take any organic waste, fecal waste, pit latrine content, contaminated water, chemical waste, and others, and turn it into clean water and the elements. So if we follow here, if you follow the air, for instance, the ambient air gets compressed into a high pressure compressor, and then it passes through a heat exchanger, the economizer, which recovers the heat of reaction and heats up the air to high temperature. It's then mixed at the entrance of the reactor with the waste undergoing treatment, and that waste is slightly preheated for energy efficiency in another heat recovery system. In a reactor, the reaction that I was showing earlier occurs, and it happens in a few seconds. We're talking about 4 to 10 seconds for the reaction to occur, and it's extremely fast because of the conditions that I mentioned earlier. And then the heat is recovered. After the heat exchanger, we have a phase separation. This is where the permanent gases and some vapors are expanded in a heat recovery and energy recovery system, resulting in power used in the system, the vented gas, and distilled water quality. Here the water is condensed and is of very high quality. The other stream from the separator is the minerals that I was mentioning earlier with some water as well, and that's fit for recovery. On the next slide, what you see is a picture of what we call the Nyx One System. This is the original prototype that was built with funding from the Gates Foundation. We received funding to demonstrate this technology, to de-risk it, to bring it to a stage that it can be commercialized. Receive about $5 million from the Gates Foundation, and about $1 million from other agencies. And what the characteristics of this system is that it's very compact. This is a 20-foot container, and this can treat the waste of 1,000 people, 1 ton a day, 1 wet ton per day. It's a continuous process, and it produces clean water. We'll show you some pictures or videos later. There's no odor, you know, with water, wastewater, fecal sludge. Odor is a big concern. There's no odor, so you can place a unit like that in a neighborhood. It also destroys every organic chemicals. There's no organics that has not been destroyed, that we fed to the system that hasn't been destroyed. And Mary mentioned PFAS, PCBs, emerging contaminants. They all get destroyed and mineralized. You can do this with multiple waste mixed together, a fecal waste plus chemical waste. Everything is disinfected because of the heat. And you can do it with waste without dewatering, without drying. Now, there's certain requirements as to the concentration of organic, and I'll get back to that. But the beauty of this process is it's relatively simple. It produces very clean effluent, and you don't need dewatering. On the next slides, you see more pictures of the system, how it is in the interior. It's all industrial equipment. And some further attributes that the units are small, and you can locate them on the premise, embed them at the source. By the way, my background is inside the unit as well. The pictures you see here is before the thermal installation was placed. And very relevant, I think, for the audience today is to realize that, you know, we recover and we can reuse water. We can treat fecal waste as we mentioned, but recover energy from it. Recover nutrient. I think in today's context, I know India is going through a huge revolution where initiated by the Swachh Bharat mission, but also some of the stringent requirements placed on wastewater treatment. There's huge demand for toilets, there's huge demand for small scale systems, and we think this solution has a role to play. And so in decentralized units. The process is very scalable, so it can fit multiple needs. And it's very energy efficient. And as we started talking about sustainability, Doug mentioned the sustainable goals. It's really, I think, very relevant to that. Next slide, please.
It's very.
And on the video, what we'll show you is the ability of the unit to treat a variety of waste. As I mentioned, you know, we've done a lot of work on biosolids and fecal sludge, but this particular video is showing that we are adding microplastics just to show that we can treat ground plastics. We can treat waste oil. We can treat yes, and that's gist of this video.
Can everyone see the?
Yep, we can see it. Thumbs up.
I'm going to take away the music in the background, and so what we have is we have biosolids at the bottom. And then we're adding plastic. The plastic is not is not a feedstock. It's not necessary. It's just adding to the demonstration of a blended waste of biosolids, wastewater, think of those as being microplastics. So we're demonstrating that we can treat plastics, and then we're going to add some foods, fats, oils, and greases. This is why we have a cholesterol treatment medications in the world. But so that's going to go into the now this is at the Nyx One. This is at Duke University. That's a Duke University pilot system that 374 Water uses under a sponsored research agreement for treatability. But what they're doing here is making that uniform, consistent feedstock that's about 12 to 15% total solids. They're pouring it now into a feed hopper where it will go from a low pressure pump into a high pressure piston displacement pump, which will then move it through the reactor. That's the actual material that's going into the system itself. And what you're going to see is there's the Nyx One, the blue container. It's a 20-foot cargo container. And voila, that's what comes out, minus the gases that are coming out, but that's it. All those solids, 99.9 or higher percent removal of volatile solids. COD reduction goes from 160,000 parts per million or 200,000 parts per million down to about 118 parts per million. Any organics that might be in there, microplastics, drugs, if you did have PFAS, anything else that's in there is generally going to be mineralized to CO2 and H2O, and then any inorganics there are going to be oxidized to the lowest oxidation state of whatever else is in there. They may form precipitates with other compounds. They may just be in an ionic state, but that's it. So that's the idea, behind our solution. So now what I'm going to do is I'm going to go back to the slide presentation. And I think at this point, why don't we stop, Mark, and just see, let me see where we are next. Yeah, well, let's stop and take a question. If there's any questions about the technology.
Get to the next slide, next two slides, and then we can take questions.
Great.
No, get on the slide that shows the minerals right after the video.
Is this what you want to show?
Here's more. Just again showing the diversity of things that go in and how clean what is what comes out. And you see a picture of the minerals, and those contain all the phosphorus. Also, just on the next slide, you have some attributes of the water effluent. Just again, we're coming in with very high concentrations. That's the feature that's required for energy efficiency. Either as COD or as a solids content, very high nitrogen, phosphorus, and then what comes out is the water, very clean. And maybe indeed, as Doug said, before we get into telling you about our global access program and our plans, let's take questions on the tech.
Yeah, so just we'll close out the tech and open it up. So right now, what you'll see over there in the dotted line is the Nyx One unit, which is the pilot system that sits at Duke University. We at 374 Water are currently in the process of manufacturing two Nyx 6 units. Those are 6 wet tons per day, approximately 6,000 human individuals, population. The first unit is going to Orange County Sanitation District in Fountain Valley, California for a demonstration project. They will be treating primary sludge mixed with concentrated thickened sludge. We will be putting that combined material, which has about a 4 to 7% total solids content, through a dewatering unit where we will put it through a screw press, and then we will thicken it up to about 12 to 15%, and then it'll go through the Nyx 6 system, where we will then treat it with the air squo process. And what will come out will be what we talked about earlier. We'll have a water stream that's distilled water. Some of that distilled water will be reused in cooling and providing water into some of the equipment. And then what's left will be mixed with the water and mineral solution that comes out of the reactor itself. And we'll be sampling the minerals to see what the mineral content is to determine if we can valorize the minerals, as Mark said, as a fertilizer. Then we are at the drawing boards right now on our Nyx 30 unit, which is a 5 times scale up. So that's 30 wet tons per day. That would correspond to the solids from about an 8 to 10 million gallon per day plant. And then there's a zero cutoff on the Nyx, that should be a Nyx 200, which is a 200 wet tons per day, which would take you up to about a 30 million gallon per day wastewater treatment plant, or the solids from the equivalent. So that is the technology, that is, and those are the commercial offerings. In terms of, people are going to ask about cost, which we can get to a little bit later, but we will be looking at doing a number of different ways to offer this through purchase, which can be a cash purchase or it can be financed. We're looking at offering leasing options, and we're also looking at an as-a-service option where we can either do it ourselves or team up with a local service provider. The unit shows up, gets connected and operates, and it's run by a contract operations or a as-a-service group. And the cost basis is on capacity and throughput of what the treated waste itself. So with that, again, we promised to pause. I will pause, and let's open it up for questions about the tech and the commercial offering. And then what we're going to follow up with, we want to leave about 5 to 8 minutes, maybe 10 minutes, or 5 to 7 minutes if we can, for Mark to just describe the Global Access Program to see how it resonates with you all and some of the things that are going on in India. And then we'd like to hear about the specific needs in India that might be applicable to a technology like this.
Sure.
Question?
Thank you.
Excellent overview. Yeah.
Yes, ma'am.
Yeah.
Go on. Yeah.
So I was just curious, in India, the water as a service or the waste as a service, is that a common model that you all use where you're able to contract out for someone to run an STP and to provide, well, obviously with tanker delivery, that would be something.
Yes, indeed it is so. And if they are, localized solutions for wastewater management, it'll be from about 100 KL to as much as probably 500 KL or 500,000 liters of water. And this is water which is only with biological contamination, not chemical. If we are talking effluent treatment, if you're talking chemically contaminated water with heavy metals and such, that is a slightly different ballgame. There are 2 or 3 technology options that are available currently in India and have been, these are conventional models of such treatment that have been here for at least the last, say, 30, 40 years. Chandra, do you have any observations to make? Neil Matthews, you have some things to offer on what the India scenarios can mean for anybody from the outside. One of you there? Chandra or I thought Neil, I saw you here, Neil Matthews, are you here? No, I don't know.
They're both on mute.
Yeah, he's there, Neil is there, but yeah, you're on mute. Professor Swaminathan, do you have anything to offer? No? Mary, this happened to me the last time.
Yeah, well, we have questions. So I think what I would like to know is, the Orange County sanitation, if you could describe what that, the stages of the process. We saw the announcement. Congratulations. It's wonderful to have a place right there in the Los Angeles area that's a definite, highly regarded organization. Harry, you're raising your hand.
Yeah, sorry, Mary. Pallavi or someone on the host side, Neil Matthews says he needs to be unmuted by one of you. Over to you, Mary. Back again.
Oh, yes. So, so you described briefly what they're doing with the demonstration project, and what made them decide that this was, a unique, or is it that they have constraints on the level of waste they can have in the area? Doug, what was the decision?
Yeah, there are several things. And the beauty of working with a public agency is you could actually, and Mary, I can point you to it if you want to share it, but you can read the agenda report, their presentations to their operations committee, as well as to their board of directors, which very, 2 to 3 pages explaining. But there's essentially 3 things. One is they're currently using anaerobic digestion. It uses a lot of power. They're generating methane, which they're reusing, but they're also, those units were built almost 20 years ago, so they're getting close to the last third of their useful life. They're, Orange County is in Fountain Valley, California. It's near a fault zone, so they've got earthquake issues. So they don't necessarily want to rebuild the next version of anaerobic digestion in the fault zones. So they're looking at the future. They're looking out 10 years and saying, where are we going to go with our solids treatment, with our sludge treatments? So they see this as an opportunity to scale up. They generate 250 million tons per year.
Wow.
So there's that. There's where do we go with the future technology when we reach the end of the useful life cycle of the current anaerobic digesting systems. The second is we've got emerging contaminants, PFAS, 1,4-dioxane. California's identified several other emerging contaminants of concern. OC does recycle, some of their water at their plant too is actually reused. So they clean it and it's actually reused in, I believe, as drinking water. So they do recover and reclaim and reuse some of their effluents. And obviously we don't want the emerging contaminants not only in recycled back in water, but we don't want to release them into the ocean or into any other receiving bodies as well. So the idea is to address the emerging contaminants. And then the other aspect of it is, looking at resource recovery. If they could, at the size that they're talking about, we could generate a significant amount of additional energy that could be reused in the form of low-grade heat and electricity. And then the minerals that come out, we've seen as much as 20% of phosphorus in the mineral that could be valorized, where they could create a stream that goes out to a local supplier of fertilizers or someone who processes into materials that can be reused. And there could be benefit there. So the idea here is the resource recovery, eliminating the contaminants of concern, and moving to a technology of doing that is more efficient, more effective, and sets them for the next generation of solids management.
Right. And as your chief revenue officer, and it's so interesting to look at the many different revenue streams and the ways to cost benefit this, because you have the transport and tanking of solids off of a property when you said the number of tons, but have you planned, or how, when you talk about generating revenue from some of these minerals, or, a polishing process to extract things that could be useful, I know that creates those revenue streams. Are you involved, or how does the utility capture those revenues? Doug, if you could talk about your vision right now.
Yeah. So what we're going to do in the OC Sand project, and we're doing with many of the projects, is we're doing what we call controlled studies. So we want to, because we're moving this into a 6x scale up and moving it out into commercial application, we want to understand what the feedstocks are, what the effluent, what the concentration and composition of the feedstock, what the concentration and the composition of the effluents are, but including what the minerals are. And we will also be sampling off gases, because in the US, we do have to satisfy the regulators that this does or does not need an air permit. And if it does, what are the parameters that might be of concern? So we're working with consulting engineering firm is a partner of ours, and they're going to be doing the monitoring, and we'll be evaluating. But one of the things we did do is we put in a translucent cone bottom tank for the effluent, so we can put the waste in there and then be able to pull the mineral samples. And then looking at the mineral samples, depending on what's in there, and the we will then be able to look. We've talked with, there's a couple of universities out there that are doing some work on recovery of minerals like this. So we do want to be able to see if those streams can be valorized. And then in terms of the water that comes out, the water can be used back in the plant. Depending on what the use is, will determine what polishing you might need on it. But you could be reduced. Some water, unfortunately, in the US, water is cheap and too cheap, but there still is an operational cost offset if you're able to reuse and recycle the water. And then obviously, if we're able to recover heat and are able to convert to electricity, that's a huge offset as well, because it'll reduce the demand that they're pulling for the overall plant, and create electricity from waste that they didn't have before. So that's the way we're looking at it. And as we go into each project, we'll be evaluating those elements to see where we can. When we do cost calculations, when Mark and I do a lot of the business cases, we generally will do, two different versions. One will be if you can't get any value, then you're just using this as a treatment system. And then the other end of it is you can valorize the minerals, you can valorize the water, you can valorize the electricity, and then we look at those.
Sorry to butt in, Doug. Can you tell us what is the smallest such system that you have set up in terms of, say, million liters per day or some such?
Mark, I'm going to turn that to you since you can move between SI and British or US units.
So it is a
you can talk in million. You can talk in million liters. You can tell me that you do 500,000 liters,
it is a trick question in the sense that remember that we don't treat the water, we don't treat the sewage per se. What we treat is mostly concentrates, residues. So there's not a one-to-one single association. But let me answer it. Let me answer it this way: is that because there's different ways it can be implemented. We can treat the biosolids at the very end, but we can also treat primary sludge. In a place that has just anaerobic settling ponds, we can treat that sludge after slight dewatering. So we look at the Nyx 6 as being a community of 6,000, the Nyx 30 of maybe 30,000, but the Nyx 30, depending on the residue, could be a community of 300,000. So that gives you a little bit of a sense.
No, it doesn't. I'll put it like this. Don't talk to me in terms of people. Tell me in terms of liters of water. You can tell me American or British, doesn't matter to me. The rest of us here will think both. You tell us in million liters if you like.
I suggest we'll take it offline so we can have a further conversation.
Sorry.
The Nyx 6 processes roughly 1,500 gallons per day. The Nyx 30 is about 7,500 gallons per day, and the Nyx 200 would be 16 2/3 times higher than the Nyx 30. So that's roughly in gallon equivalents. But as we say, we did not create this to be a complete replace a wastewater treatment plant and be a water treatment plant. This is intended to be for the solid. This was developed to be for the solids and for streams that have some calorific content, some heat content to them. When we look at like wastewater streams, if we were looking to put a system out that was going to be treating the full wastewater stream, we would put some sort of unit in front, some sort of membrane reactor or biological system to treat the water, and then we would take all the solids and eliminate the solids. So we want to be very clear about that. This is not intended to be what I'll call a clean water, source water treatment system. This is intended to focus on organic streams, biosolids, sludges, and it could also be applied to industrial and other commercial types of food waste, waste oils, fats, oils, and greases. But the application here is to, the key application here is to basically eliminate those solids and then be able to recover the resources from them. So I hope that makes it a little bit clearer.
Thank you. Chandra or anybody else, we want to add to this. Where do you see application in India or something like this? It seems to be something that comes past a regular tertiary treatment system. Sanjay Gupta, Chandra, Rana, probably anybody who wants to ask or offer observations.
We have a good question there from Swaminathan.
Yes.
Is it necessary to achieve drinking water quality? What would be the impact on technology? And I think the guys discussed this in terms of the energy cost. If one is looking at treating to discharge standards, which maybe Mark, you could answer that.
Yeah, I'll take that. So we meet the most discharge standards. From a COD, organic nitrogen. I presented just to highlight. And on the energy, so you can look at this as we're going to meet the discharge standard. On the energy, this slide's been up for a while. What you see is that the Nyx 6 is actually consuming a little bit of power, not much, but with the economies of scale and better equipment available at greater size, greater scale, the Nyx 30 can actually run autonomously just on the waste that is embedded, that drum that I was showing at the very beginning of the presentation, and so is the Nyx 200. So it's very energy efficient because it was engineered and developed with that intention.
Great. And I encountered your team at sort of a zero waste discussion, a place where we were talking about how do we meet these EHS, SDG goals of the UN, you know, and move towards zero waste. And I'm thinking about like CAFOs or those very large farm operations or places where they are limited in what they can discharge in order to add a new plant or facility. And Mark, if you could talk about that, like achieving a vision for zero waste, it seems like that's probably what the prime motivator for this extreme, you know, water oxidation. And so is there like a CAFO or a commercial entity that you had in mind as like the ideal purchaser that would want to cap the waste element of their operations?
There are many, you know, for those who are not aware of what CAFOs are, is a confined animal feeding operations. A lot of industrial farms in the US are like that. And animal farms are prime targets, and so are many other applications actually that we're pursuing. But they primary target because, you know, in a way, they don't flush the toilets at animal farms as often. So the waste already comes in a more concentrated ways. But it's a complex market as well. Doug mentioned some of the markets that we're targeting, you know, chemical waste, you know, the fecal sludge, the biosolids. There are many applications. One big one currently in the US is the market of emerging contaminants driven by fluorinated compounds called PFAS. And we know there's many pollution aspects as well in India as well, in surface and groundwater as well. So this is a quick answer to your question.
Yeah, as we move into this discussion of application and potential fit within India, what I'd like to do, if we could, is let me ask one last time: is there any more technology or understanding of our airflow or anything else about the actual units themselves? Because I think as we move into Mark's discussion about the Global Access Program, you will be able to provide us valuable feedback if we're going to be satisfying a true need in a way that it can reach your markets, or whether or not we need to adjust our trajectory. The other thing we want to make sure that comes out clear as we talk about the global access, we know that we're going to need local partners. That could include local service providers. It could be local manufacturers. So there are commercial opportunities here to create partnerships or entities within India for employment, for distributing this technology, for manufacturing it. So there's also commercial benefit as well to the Indian economy, and to so there's two sides of this. There's one is the what the systems does, but then there's the ability to partner and help us distribute this to the folks that might need it. So any other technology questions or things about?
Good evening, Mr. Doug. This is Sanjay Gupta here. I'm good. How are you, sir? I am based out of southern India, a city called Hyderabad. We are into solid waste management systems in South India. We basically are operating at residential communities and industrial installations. I have a question here. Suppose we have a residential community of around having around 50 KLD, that is 50,000 liters a day as their wastewater, and we plan to install such system AIRSCO on their community. Firstly, what space would it require? How much space and cost would they require?
Excellent question. Mark, do you want to talk to the sizing?
Yeah, I mean this from a quick mental math, I think fits with the Nyx 6, which is 140-foot container. Doug, you want to talk a little bit about the cost?
Yeah. So when you talk about the Nyx, the what we call the Nyx 6, the 6-foot ton per day, most of the equipment is inside a 40-foot cargo container, And then there's some ancillary equipment that expands the footprint a little bit. But you're talking, I think we've estimated it probably takes anywhere from 1,000 to 1,200 square feet. And I'm sorry that I'm using US units. It's been a while since I've done international business, so I've gotten rusty on making quick conversions in my head.
Oh, no, that's perfectly okay.
Yeah. So it is a relatively small footprint. Sometimes we'll show a slide that if you look at this, we have worked with a utility in the US in the North Carolina area, and they generate enough biosolids or sludges where they would need 2 Nyx 30 systems. So we show the footprint of 2 Nyx 30 systems against the footprint of the equivalent in anaerobic digestion. And you're talking probably a 200% decrease in the amount of land that you need. So it's a significant space reduction from competing technology. So from that standpoint, from a cost standpoint, the manufacturer's suggested retail price, and this is not necessarily what the final price would be, but a capital purchase price is roughly 2.4 million for the Nyx 6 and roughly about 5 million for the Nyx 30. We estimate the operations and maintenance costs to be about 5% of the capital cost per year. That does have an assumption that it's about 1 full-time equivalent, and it includes the cost of electricity that it'll pull for startup, shutdown, and operation, parts, and normal maintenance of the system. We usually do our business calculation or estimations over a 20-year life cycle to be able to come back to either a net present value or a present value cost. The way we see, that's the capital purchase approach. We also see this, as we say, as a leasing approach where you could pay on a monthly or an annual basis, depending on how the lease is structured. And then the as a service would be based upon the economics of the throughput and the capacity. But that will give you some idea, at least, of that. And again, that is MSRP. We do recognize that in some of the emerging markets that we may need to discount those MSRPs to be able to be more closely in line with what could work. But that's where we're at right now in terms of being able to provide estimates.
Great. When I evaluate the value of, say, $2.4 million, which works out to approximately 17 crore Indian rupees. Am I right in that, sir? At 75 rupees, would that be for a 50 KLD plant?
Yes, that's right. It's more. Actually, what he's saying is this, Sanjay. He's saying Nyx 6 will cost you at the baseline 2.4. And after that kicks in the second part from Nyx 6 to Nyx 50. Okay. So, and that part is another 3. That's 5 million. You're right. So you take 5 million multiplied by what is your figure?
75 plus duties and taxes. Yes. Okay. Fine.
Yeah. So in fact, yeah. Yes, Sanjay, please.
It's always we want to be transparent with that, but it's always a challenge to talk, commercial pricing when you're entering a new marketplace, because we need to engage. This is one of the things that through the Global Access, Mark and I are looking to do is engage potential commercial partners and folks who have the need to help us better understand what the economic situation is, so that we could see how we can model, commercially and financially model an offering that will fit the local economy and the local business case, if you will.
Exactly.
So we want to be transparent and not duck the question, but we also recognize that, so tell us, is that a lot, is that a significant cost for this based on, the lens through India?
Sanjay or Chandra, one of you.
Swaminathan had some comments on this too.
Sure. Yes, please. Mr. Swaminathan, you want to speak? No. Okay, let me tell you. let me first respond. Sanjay, you must be willing to respond just now.
I'm sorry, could you repeat
No, the question is this. The question he's asking is being very transparent. He's saying, look, I don't understand what your economic scenarios are in India. If you can give me an idea of what the prices are, we are willing to see what we can do to look at it and, recalibrate ourselves. In effect, that's what Doug was saying.
Recently, we have started discussions with the public utility services in Hyderabad to manage fecal system flowing, to stop fecal system flowing into the Musi River, which is highly polluted at the moment. So we are probably having another meeting with them coming week. But everything, sir, as you know, in India, the pricing cost, it's a very cost sensitive market. So we'll have to really work out the commercials and the social benefits to see the viability of its applications in India. More so, it should be where the quantities are large. Maybe we can get better output, because local technologies, we talk in terms of maybe a few $1,000s for a 10 to 20 KLD plant, a sewage treatment plant. That's how it works out. So definitely, but this system on a larger scale, if it can help to save our water bodies, which is the major issue in India. We can definitely like to work out on that.
Yes, I think this is a good segue. We've got a little bit of time, and I think it's really important when I invited Mark that he can convey this global access program to you all, because I think this is where the jumping off point is to find applications and business partners. So if you all don't mind, I'd like to give Mark a chance to discuss this, because this really gets into what we just said, which is how do we penetrate the Indian market? Who is available that we can talk with, who might work with us, and who is there that might actually want to partner with us to bring this to fruition. So Mark, I'm going to turn it over to you.
Yes.
Probably not best to read each slide, focus the highlights because we're getting tight on time, but let's make sure that we convey an action at the end.
Absolutely. And we just have 2 slides. So I want to take a couple minutes to talk about our global access program and maybe how we can work together. We're looking to put a unit, a Nyx 6 unit, and we talked a lot about the Nyx 6 in India, and do a demonstration with an active partner there. We're focusing on fecal sludge, but it could be also industrial waste. And we're looking at doing a technical demonstration as well as a business economic demonstration. And for this, we're looking for partners. So this is a call out for partners who are ready to work with us on this demonstration, but also take it and scale it, and work also, as I mentioned, on business models, because we believe that our technology is a formidable solution, a transformative solution. As we said, there are constraints, there are challenges. So on the next slide, just a little bit showing you what the master plan is. Doug, if you could advance to the next slide. Doug, can you switch to the next slide?
Okay. Mark, are you looking for me to advance?
Yeah, next slide, please. Yeah, next slide.
Sorry.
Yeah, and so that's kind of an overview of our plan for this demonstration, for working with a partner in India or in another emerging economy, is working with a partner who has the credential, the guts, and the vision to work with us to put a unit and develop it into a fruitful business, so that we can do good for the society, and they can be a profitable business. And so that's the selection of the commercial partner, which is on the left. There's no question that we will need to work with government and have a tight relationship, friendly and fruitful relationship in advocacy with government. We will need funding, and we're well positioned. We have started pitching, and we have, of course, great connections with the Gates Foundation, but also with the World Bank, and others. And we're looking to launch this demonstration soon. So for a duration of about 2 to 3 years, because it will take time to put the unit on the premise, but also train the partners and local operators, and then build a model that it can go to scale. And certainly, cost is an issue, but there's, cultural aspects as well, and technical demonstration. So that's, in a nutshell, what the overview of our plan. And again, I want to put out a call here for those of you who recognize themselves in a potential partner in any capacity to reach out to us. And with that, I will.
Mark, I'd like to also mention that we have had some contact from some industrial entities in India. We are in conversations with ART Industries for some of their industrial wastes and wastewaters. We've also talked with Dr. Reddy. So we have had some inquiries from some industrial corporate entities within India that we're having discussions with. So, we have both the private, what I'll call this public and this private approach. So, because we figured that whether it's a commercial application or a public or a wash application, the key thing is to find partners and to establish a presence and see if we can make this work within India. And then we would take that model and take it to other emerging countries as well to be able to provide the same benefits.
Got that, Doug. Rana, you've raised your hand for a while. Would you want to?
We're done. We can finish up with questions at this point.
Will you want to speak, please? Rana, do you want to speak? You raised your hand. Okay.
MD Rana? No?
Yeah. He's
yes.
Yes, please.
Here he is.
Can I come in?
Yes, please.
Can I come in?
Yes, we can hear you, sir.
Yeah, I'm from Gujarat. Good evening.
Good evening. Good morning. Good
morning.
afternoon.
I have been in difficult water treatment business for almost 10 years now, and overall water business 50 years. Your model is specially not meant for water exclusively. It is entirely different. It is solid waste management along with wet. And I fully understand the concept. Before joining your session, I had a little bit studied about your product, and I'm keenly interested, and it is a tremendous market in India. The company you mentioned, I already know them, Aarti. That is, in number of places. Number two, Reddy's also I know very well. I have worked and understood their problems also. And we can definitely work not only with the industrial association, number one. Number two, with the government. And once technology in the place, we can make sure the government implements this positively. Thank you.
Thank you, Mr. Rana. I'll let me, if it is all right with both of you, with Doug and you, I will put the two of you together, keep Mary Eggert in the loop, and maybe, you can discuss and see what these barriers are to, getting together and working. Kundala Rao, can I request you to speak, please? You're raised your hand.
So good morning and good evening for different people, different. So I'm basically a consultant and a guest speaker, guest faculty with engineering staff college like that. I'm into water and sanitation and fecal sludge management, etc. So sorry, I have joined a little late. So is the technology a thermal one? Thermal pyrolysis or like that? What is that?
No, go ahead, Mark, please. It's technical.
Yes, I mean, it is a thermal, but it is not pyrolysis. It's not HTL or HTC. It is a wet oxidation that is done.
They use a heat exchanger, Mr. Rao.
Okay.
Yes, and we do it in the liquid phase, in water, in supercritical water. I believe the session is being recorded, but otherwise just get in touch with us or look at our website for more details.
No, I'll enable a conversation for you, Mr. Rao, if necessary, but go ahead. You wanted to say something more.
Yeah, actually, because there is a lot of potential for fecal sludge treatment plants in different parts of the southern states. So there, one is the biological treatment way, process, and the other one thermal treatment process, which I am familiar with.
Lovely.
So this seems to be a different one. SCO means what is the full this thing?
Mark, what does SCO stand for?
Supercritical water oxidation. Supercritical
okay.
water oxidation.
That's all it is.
Yeah. Okay. So
Yeah.
can I have any, brochure like thing?
We'll get there. Mr. Rao, what I'll do is post this chat today. Thank you for engaging. We will see. This is essentially what Tech Talk is about, Mr. Rao, and all of you, ladies and gentlemen here. So what we'll do is after this, we will send you to Mr. Rao as well as to, the others who have been asking, Mr. Sanjay Gupta and, Nilesh, for instance. Maybe he wants to take something. Mr. Rana has asked for it. We'll see how we can exchange some notes. Mr. Raval has some things to say. Yes, put that down there. Raval ji, aap kuch kehna chahoge abhi? Mr. Raval, you want to say something?
Nothing.
No,
Nothing.
that's fine. We will go ahead further.
Okay. Yes, Mr. Rao. Anything else? No. Okay. We'll come back to you, Mr. Rao. We'll come back.
Fine.
At 7:04, we still
Thank
have time. We have another 10 minutes.
I noticed Dr. Raj has joined us, and
Yes.
he
Yes.
very excited. He and I talked about this technology and the potential application, and
Yes.
I
Yes.
know that Raj, it looks like you're on mute right now. We'd love to have your thoughts on this potential application. Both you and Hari are drivers on making things happen. So what are the pieces that we need to put in place, or the people we need to connect with this to make something happen with the demonstration and move this technology forward? Dr. Raj?
Thank you, Mary. Thank you.
Thank you.
Doug and Mark, I've been involved with the Water Reclamation District in Greater Chicago for some time, and they have tried several chemical treatment technologies for their sludge, which is in large quantities, as you know. And they have a very expensive plant. They spent about $500 million, managing their sludge and creating it into solid products, which they market and as fertilizer. Have you looked at how you can compare your technology versus technologies offered, which are chemical based, whether nitrate removal, phosphate removal, they do of the sludge? Because that is something to see. The US market itself, we are looking for many competitive technologies for managing the huge amount of sludge that we create in our treatment plants.
Yes, and in fact, the beauty of the supercritical water oxidation technology is it is one of the only solutions with incineration that results in the ultimate volume reduction. I am myself a big fan of anaerobic digestion, and I conduct anaerobic digestion, but you still have sludges that need disposal at the very end. And currently there's a lot of pushback on such sludges because of emerging contaminants. And there's a place for anaerobic digestion in our economies, but we think there is also a place for the systems we commercialize because of these other constraints that I mentioned. Sometimes you do not want to have any residues. And so that is one of the attributes. You have complete disinfection. There's no living organisms left after supercritical water oxidation treatment. And you have the ability to recover the minerals in the water. So these are some of the differences with the other sludge treatment technologies. There's a lot of focus these days on making biochar or making some sort of thermal treatment. Generally, these end up with some nasty residues, some tars or some phenols, or result in a lot of emissions. Like by making biochar makes a lot of carbon monoxide and odors. And when you put it all in, we think the AirSquo is a very favorable technology, also from a greenhouse gas point of view.
Okay, I'll put you in touch with some people at Water Reclamation District of Greater Chicago, and you can see how they would be receptive to this. Thank you.
Did you say Greater Chicago in the US?
Yeah.
Yeah, we've been in touch with them. We know that they're doing an evaluation of several different processes. So I know last we had talked to them, they had put us into the consideration set of for their biosolids master plan and future technologies. But it's a long-term project, so we have not heard whether we've progressed or not. But if you could, put a kind word and share a contact with us, we'd love to circle back and see how things are going there. Thank you very much.
I'll do that, Doug. Thank you.
Yes, Raj is active, started up Techtalk in India, but is based here, fortunately, right by us in Chicago, where Global Waterworks is also based, and just an excellent advisor for solutions that can move the needle forward. And I put in the, yeah.
I'm just gonna say we've been talking with Techtalk about some of the PFAS challenges at the DoD bases in the US.
Wonderful.
Very
So
helpful.
again, we'll continue to take questions. I think, Mary, you're facilitating on the time, but more questions, please. We're here for you.
Yeah, thanks. I want to comment, a few people have mentioned other technologies, and Frank Slavenik of our team has created a wonderful database with Graham Simmons that exists on the Global Waterworks site, which everyone is welcome to reference. I put a link to it here, but also invite suggestions. If there are technologies that are transformative that we're not talking about, some of you have mentioned here, we invite those suggestions, and I put Frank's email in here to the chat. But I noticed a comment from Upendra Raval on the sewage treatment plants and the comparative sludge and treatment capacities. Maybe you could open up your mic and share specifically with Doug and Mark. Or we could read off the questions. Oh, I see Mark is already responding. Mark, if you want to comment on that.
Yes, when you conduct biological treatments, like many do, sewage treatment plants, biological treatments, anaerobic digestion, you care a lot about whether it's biodegradable, whether it's, it's in the form of polymer. And there was this comment made, feces is not the same as biosolids, and that's absolutely correct. But when it comes from a treatment point of view, using supercritical water oxidation, they all get oxidized. I would say all molecules are equal when they're facing squope. They oxidize very easily. We do not care about the BOD to COD ratio. But the only thing we care about is the calorific content, because that's how the units are end up being sized. Because it's such an intensive physical thermal process.
Excellent. Any other questions, comments?
Yeah, can I speak?
Yes.
Oh, so actually, has this technology been piloted or been implemented in India anywhere? No. So far?
No, it has not. And we would love to.
Okay. So you need what is the minimum calorific value you need for implementing this one?
Typically, when we feed the system, it's at around 2.3 to 2.5 megajoules per kilogram. Or often when we think of it in terms of COD, the chemical oxygen demand, in the range of 100 to 150 grams, not milligrams, grams. So we treat slurries. We showed pictures. Best examples are slurries.
Can I come in?
Almost 10,000. It's almost 10,000 milligrams per liter.
Yes, correct.
100,000.
Yes,
100,000 to 150,000. Mr. Rana?
Yes, this is basically technology for not sewage treatment and conventional treatment. This is specially meant for difficult water, which is conventionally on chemical treatment or biological treatment not possible. So it comes, very complex, and this type of water can be dealt with advanced oxidation. I'm not talking about ozone, UV combination and all that. I'm talking about electrode specialty, which is not even ceramic. It is platinum or maybe diamond electrodes. That is the only solution. So this is, very interesting, very specific treatment system, and it requires, different, set of people to understand, not conventional way of dealing it. Thank you.
It's wonderful to get your insights on this and to know that innovation is happening to address this very difficult area of waste management. So I think we're the idea of the EHS or handling this environmental challenge that we have with these emerging contaminants and problems, slurries, is a reason we created Global Waterworks so that everyone can find solutions. And also we are so excited to have the WOW forum of experts in India. So everyone should have Doug and Mark's emails in the chat, and we welcome your suggestions if you want to put your emails in there so that they can keep you apprised of pilot development and their movement in India. That would be wonderful. I know we usually have the International Center for Clean Water here. I don't see Sripati or Nanda Kumar, but Doug and Mark, I wanted you to be aware that out of Chennai, they have a leading research effort that could potentially document a case study or be involved when you're ready to do that. But Doug, you were leaning forward. Was there more that you wanted to share on global access or more questions you had of the group?
No, we were going to say, I was going to say that we'll take the presentation that we had and press it into a PDF and share it with you, Mary. And then if you want to share it with the attendees or anyone who was registered, that would be great. And in there will be Mark and my email addresses. But we would appreciate anyone who would like to pursue discussion further on this, that we get your email and so that we can reach out to you and start a one-on-one dialogue.
Sure. We will work on that because, I can see
Thank
Mr.
you.
Rana, Mr. Rao, as well as Mr. Sanjay Gupta are all interested in their different ways. We are a large country, you know that, and we are at least 4 times your population. So the market is clearly even better than that in China. And this is by far the largest market, therefore, in the world in that sense. So let's see what Mr. Rana seems obviously connected into some of those government processes, just as Mr. Sanjay Gupta is. So let's see who comes up. We will see how we enable some conversations, exactly what we do as platforms at both WOW AF and Global Waterworks. We'll take that up from there. Anyone else who wants to speak? Chandra, do you have anything? I know your questions at the broader level. No, you have already said your piece. Okay. And Ravalji, I think your observations are all very accurate. I mean, Mark has also sort of acknowledged what you're saying. You can come back to me maybe, offline, or the conversations that you and I have, and let's see what that means to us, Ravalji. I'll be happy to speak to you. Benedict, yes. Would you want to speak as the editor of a newspaper who spends so much time on these things? Would you want to say something, Benedict? Ben, if you're there. Mr. Rao, you want to speak again? You have raised your hand.
Oh, I have already spoken. Thank you.
Okay, you have.
Yeah.
Yeah, Benedict here.
Perfect.
Yeah, can you hear me?
Yes.
Yes, we can.
Yeah. Okay, so I'm keen to know how disruptive is this technology, because I think there are lots of other technologies around. Is it a disruptive one? And if it is, in what way is it disruptive?
Mark, you want to take that?
Well, I have a lot of experience in water and sanitation and waste treatments, and I've never seen anything like that. I think it's truly transformative. Of course, I'm completely biased. Everyone recognizes that. I think it is truly transformative for many reasons. The energy and the effluent and the output. But I don't have. I have a crystal ball, and it's telling me that it's going to make a big difference. But maybe your crystal ball has different things. I don't know. I hope mine is right. And we're believers at 374 Water. We're believing.
Ben watches, all the crystal ball gazers as a journalist. He's been writing for the last 30 years on various things. And so He is a gazer of crystal ball gazers. Okay.
Yeah. In terms of disruption, I think where it's disruptive is to the existing in the biosolids and the waste treatment models. It's very disruptive to what I'll call the more the dirty technologies, the ones that have been around that are processing and transferring the materials between different environmental media, but not giving complete elimination or complete conversion. So anaerobic digestion and incineration, I think it's disruptive to those two. It's not going to be disruptive to every waste stream in the market, but it will be disruptive to certain waste streams. For small and medium, for wastewater treatment plants that are smaller than 10 million gallons per day, if you're looking at a greenfield site that doesn't have sludge treatment, this is more cost effective, more space efficient, and more overall energy efficient than going to a THP or an AD, so it can be very disruptive at the small to medium plants where they don't have biosolids and sludge treatment, but they do want to put something in, because it changes the whole paradigm of what comes out. There's no methane, there's no biosolids to land apply. That whole thing changes. So that's where the biggest disruptions. And the other disruption is where you have regulatory agencies that have banned certain things from being able to be incinerated and land. What do you do with it? We can go in and we can actually eliminate those contaminants. So that's where we see ourselves being very disruptive. So to answer that question more specifically, and I know we're out of time. So.
Yeah, so we're about to wrap up. Before we do, what's really neat is India is disruptive with 4 times the population as the US and 1/3 the space. You have a motivation for driving technology forward. And what we'd like to do is track the involvement with this technology. If everyone could open up their camera, I'll take a picture of the group that's sort of helping to provide input at an early stage so that we can share with people. You were there when we first started talking about this. And I'll give another moment. Benedict, maybe you could open up your camera, and Nikki, if you're there, and Kandala, anyone who's got cameras. It's so small, you won't be able to see anything if anyone's concerned, but okay, smile. Great. We will just document this in the, I'll take another picture here. Thank you guys for coming on. I know it's evening time in India, but great to see real people, and it's through real people that we actually make change happen. So, great to have you here. Talking, but if you have something to add, that would be great. The last thing I'd like to end with, because we want a great vision, and you just said, Mark, this disruptive aspect of our technology potentially creating a different future 5 to 10 years from now. How is the world different? If you could just explain, like, because this was adopted, changed things, the world that we're in 10 years from now looks different. Specifically, how?
You're asking me?
I am, yes.
I think, you look at our infrastructure and how we handle waste, and it's really a legacy thing where, we've inherited and we haven't really looked at it with a blank slate. I think.
Please, sorry.
We lost Doug.
Yeah, what I want to say in closing, I've got to jump to another meeting, is that what I think we're going to see in 10 to 15 years is we're going to start to see the regeneration and the cleaner receiving waters, and start to see our environment less polluted, and starting to decrease the amount of material that's getting out, raw sewage and wastes that aren't treated. And we'll start to see some rejuvenation of our water bodies and sources. I do have to run, so thank you all very much.
Thank you, Doug.
We have to be we are past our schedule. Thanks so much to you, Mark and Doug. Thanks, Raj, for being here.